Hi guys, my name is Shayan farahbakhsh and I was a project leader for group number 3 for EC474. Welcome to my video. The topics we'll be talking about today are the chassis design, which I did on AutoCAD, which is part of the technology, as well as the robot movement algorithm, which are the line sensors, which are the concept part of the video. Here you can see the chassis design, which was done on AutoCAD. On the top you see a rectangular shape, that's the gate, which is attached to the robot. Our robot worked kind of like Pac-Man, so there were two balls on the maze, so it would go eat the balls, and since the gate is only one-way gate, the ball could not move out of the robot. We used two stops for that, which I'm going to show you in the final image of the robot. And so that's how our robot worked. I used water jet cutting for the robot, and in order to do that we had to have our format in the .dwg format, and AutoCAD does that. And as you saw previously, there were no dimensions on the drawings, and that's due to the fact that for water jet cutting you're not supposed to mention any dimensions on the drawings. And you also have to make sure that everything is to scale, and you have to tell them in the email the thickness as well as what type of material you want to use for your robot. We want the robot to be as light as possible, so we use 1 millimeter thickness as well as aluminum for the water jet cutting part. Here is the image of our final robot. Um, you can see that there are two stops here, which I talked about previously, and these two stops prevent the gates from opening this way, so the balls could only go in and they cannot come out. Also, our PCB was grounded, so we had to use plastic stops, plastic spacers, you see here, to prevent it from short-circuiting. But this is the final robot minus the gate, which we attach later on for the competition here. As you can see, it's pretty small and it's very light too. And now I'll be talking about the concept part, which is the robot movement algorithm. As you can see, we have 4 different sensors. This is the 2 in the back of the robot, and these are the 2 in the front of the robot. And because of that, we have 16 different cases which are shown here. This was the cross that the robot moved on. Let's say we have 0, 0, 0, 0. And by the way, 0 means the robot is detecting white, and 1 means that the robot is detecting black. So if we have 0, 0, 0, 0, that means that they're all detecting white, so that means they're here. So we want the robot to move back to go back on the cross. And if they're all white, they're all ones, that means the entire robot is here, so that means they're all detecting black, so we want the robot to go forward. Let's look at a more complicated case. If we have 0, 0, 0, 1, that means the front left, 0, 0, 0, 1, so the front left is detecting black, so the robot is here. So we want the robot to turn left and go back on the cross and go forward. So we give it a left command, which is an X command. So this is the basic algorithm for our movement. Thanks for watching the video. I hope you enjoyed it.